All right, well, good morning, everyone, and welcome to today's session. This is Larry Dorch, moderator for today's event, covering the new capabilities and enhancements of the latest Solid Edge version, ST7. All right, the agenda today is pretty simple. After some brief introductions, I'll pass things off to our presenters to demonstrate what's new and exciting about Solid Edge. Then we'll wrap things up with a quick question and answer session before bringing today's event to a close. Before we get started, though, we do want to ask a poll question, understand the user level that we have online with us today. So you should see that popping up on your screen here if you haven't already. So it looks like, okay, we're getting quite a few votes in. I guess Dylan and Sam, you can see that on your end as well.
Yep.
Like we mostly got ST6, quite a few ST4 users online with us today. Okay, great. See if we can get the PowerPoint going again. Okay, so on the call with me today are application engineers Dylan Malik and Sam Estrada. A little about Dylan and Sam. Dylan has been using Solid Edge for nearly 19 years, going all the way back to 1995 as one of the first beta test groups at Martin Sprocket and Gear. Dylan also worked for 7 years as an application engineer prior to the merger with Swoosh Technologies. So altogether, Dylan has many years experience with Solid Edge, specializing in surfacing, sheet metal design, and model rendering. And for a little background on Sam, Sam has over 18 years experience in industrial industries, focusing on design and manufacturing. Today, Sam is a leading application engineer with Swoosh Technologies, aiming to accelerate industry design processes and increase collaboration throughout the product life cycle.
Hey, Larry?
Yes?
We can't see the PowerPoint. We can see the poll still.
Well, I closed the poll. Okay. All right, let me try this again.
There we are.
Okay.
Topics covered.
Okay. Well, you should be able to see on the screen right now the topics that we'll cover today. So you can see we have a lot of material to cover within the hour. So I'll get things started and pass this over to Sam so he can begin covering the new 3D sketch capability in Solid Edge.
Hi, everybody. I'm Sam. That's my mug there on the screen. Let's see. Let me go ahead and show my screen here. Okay. Everybody see my screen just fine?
Yeah, it looks good.
Good. So, all right. So, like Larry said, we'll be covering some topics here. There, some new stuff that's inside Solid Edge ST7. There's over 1,300 enhancements again this year, so there's a lot of different things that they added in. We're going to focus in on some of the major changes that they've made inside Solid Edge. So just kind of stay tuned with us and our blog and everything else. We'll be putting on some other webinars showing you some other the enhancements they're coming along. To start off with, I'm going to show we got brand new 3D sketch capabilities inside Solid Edge ST7. So for you guys that have used ExpressRoute and inside the assembly environment before, you kind of had a little preview of this capability, but now we have 3D sketch inside the part environment and the assembly environment for that matter. We can create lines on multiple planes. You can use this in sheet metal as well. You can create a tool for creating swept operations. You can also have it for creating pipes and other wires or any line that has to be bent to more than one plane. So this is one of the cool little features that they've added in. I've been kind of looking for it personally myself when I first started using the program, so I'm excited to see this in. No more having to create multiple planes and having to rotate the view around to get the line to go down to the angle that you want it. You can create these intricate different type paths now very easily. It'll also accelerate your design and get you going a lot quicker. we'll be taking a look at a little. I got a little demo set up that'll show you how this tool works out. Another enhancement that they made is something that we're going to call fixed curve length. And what this allows you to do is, before for the people who've been using ExpressRoute and stuff like that, the curve that you draw in between 2 points was always kind of a variable length. You can never lock it down. Well, new in ST7, what they give us the ability and the capability of doing is going in there and being able to set the length one and then lock it down. So when we make a synchronous change, that curve length doesn't expand as you're making that change anymore. We can be locked down, and then it can follow the change and stay at that specific length as you go in there. And I'll show you on this turbo as I rotate this cylinder right here, the wastegate. As I turn that around, you'll see the curve stay in fixed at a fixed length, and you'll see the hose actually follow the path, and it won't stretch out anymore. So it's a powerful tool if you want to constrain some of those curves. Now we do have the capability of that, and we'll show you. We'll kind of go through that. I also got a couple of other extra little goodies I'll show you too. We'll kind of get going through the west of my portion of the webinar, and then I'll switch over to Dylan, and he's got a bunch of cool stuff too. So with 3D Sketch and a fixed curve, I'm going to go ahead and jump into the demo. I'll also show you some of the other things as we start off. One, they've redone the splash page. You'll see this. This is pretty cool. The other thing you'll notice is your basic templates have been, the way that it stores your templates and your standards has changed a little bit. Now instead of having to, when you first install the software, you pick a standard to go with, you now have the capability of automatically switching all your templates out at once. So they've added in this new template creation wizard here. So if I want to switch back to inch, I can just simply click on inch, and it displays all my templates there automatically for me. If I want to switch standards, I can automatically go to that. So that's some of the pretty cool changes they made here in the splash screen. So to get into my deep fryer, I've got this set up, and I'm going to create a 3D sketch to help create a guide for this deep fryer, for this little rack that we have in here, to travel up and down. So what I'm going to do is, there's my deep fryer. I'm going to go ahead and switch over and just take a look at the actual lift guide. Here we go. And what I'm going to do is I'm going to do a 3D sketch, and I'm going to draw in that piece of stainless steel, since this is a food product. This piece of stainless steel is going to come up over here and come back in and around to help guide this lift handle. And to do that, I'm going to go ahead and place activate. Come into the actual part here, and I'm going to come in here and create I'm going to create a part in place right quick. All this is pretty much standard operating procedures for you guys in ST6, and some in ST5. They kind of redid it. So if you're looking at this from ST4, this is all kind of new to you. Let's see. I'm going to go and create. Let me change my standard real quick. Let me go to let me keep metric. We'll go to a part. I'm going to go ahead and set my material over to stainless. I'll go ahead and brown this guy. And I'm going to go ahead and add another part. Deep fryer. Let's see, that's my designation. Let's see, 0023. And this is going to be revision A. So we'll create this part right quick. There we go. And let me go ahead and show my background. The other cool thing that they've done in Enhanced inside 7 is my background pieces now show up with a little bit of shading, so they're not, the dull color that they were in previous previous evolution ST6. Oh, let's go ahead and delete all that now. We don't need that. Now I'll go ahead and give my set up this file properly. With the document, let's go ahead and give it a revision, and this is going to be my lift guide. There we go. Let's go ahead and save that. That way my I got my document showing along with my project name down here inside my Pathfinder. Now I'm ready to go ahead and start designing with my 3D sketch. You'll see up there in my menu ribbon, I have a new tab called 3D sketching. I got my line commands. I also have a 3D relate tool, 3D sketch relate tools. So similar to the 2D sketch relate tools, I now have a 3D IntelliSketch. So this kind of mirrors what we had over here in 2D, and we have the same capability now in 3D. To activate these, I simply have to go over there and click on one of the line commands. What you'll also take notice that I have the expanded help that is now new in ST7 as well. Some of the most popular commands will have a flash animation. Others will just have an expanded readout. You can turn these off at any time, but if you're new to the software and you're wondering, what each command does, we do now have these cool little flash animations that'll actually take you through a quick little demonstration of what that does. You'll kind of see these popping up every now and then. That's something to look forward to whenever you do get ST7. So to get in my 3D sketch, I just went over and click on line. And what I'm going to do is I'm going to start creating this little lift guide using my geometry that's back over here. So what I'm going to do is I'm going to go and zero in on this back circle here and lock onto that center point of that line there. Oh, let me go into 3D sketch. There we go. And you can see I have my Orient Express pop up. This is going to help guide my lines. And I can just simply come over here and click on my center line, the center of the circle. There we go. And as I come out, you can actually see at the end of my cursor, you see a little trident that's coming out. That is an actual, part of my IntelliSketch that's helping me maintain and recognize my coaxial alignment. So as I come over here and extend this line out, let me rotate my view a little. I'm locking on and staying parallel with the center line of that circle. And there it is. Center line of my circle. Now I'm just going to go ahead and quick draw a straight line right there. And as I rotate my view around, you can see I'm actually going through the center of the circle, coming out the front part of the back side of the handle. And then from here, I'm going to go ahead and go to my front view. Kind of come down, and I'm going to go over here in between this little sheet metal part, and I'm going to kind of guide this all the way down through here, as so. And if I rotate my view around again, you can see I don't have to create a new plane. I don't have to switch over, stop the command, go into a new part. I can automatically come in here and just draw a line parallel going on this side. Let me go ahead and move my Orient Wizard, my Orient Express down here to the bottom. That way we can take a look and see what's going on down here. As I change my view around, you notice that if I want to make this line parallel and make it a straight line, as soon as I come over here, it's actually snapping. And if you look at my my Orient Express, you see the Y axis that gets highlighted in orange. That means I'm drawing it a nice parallel to that axis, and that line's going to be nice straight, and there's going to be a parallel relationship automatically added to it. If I wanted to specify which axis I need to draw on, I do have that option. See here, I can draw in the Z direction, X direction just fine, Y direction. So you can lock on to each one individual axis, which makes laying out these pathways really, really easy. The other thing we can do is the same capability we have in Sketch from going from line into arc. We have that capability as well inside 3D Sketch. So I can go straight from a line straight to an arc. Let me go ahead and kind of put this little curvature in here, so we can go straight into that. The other thing too is remember the 3D relate commands. Right now I've got this line just kind of going straight down, and I need it really parallel with this guide right here. So I can add in a quick relationship parallel from this part over to that face there, and you can see it automatically straighten up and give me the correct degree there. I can also come down here and apply some relationships to the center of my arc. Reason I want to do that is because I'm only going to draw the one half of this guide, then I'm going to go ahead and create the sweep, create my protrusion using a sweep, and then I'm just going to mirror that over to the opposite side to finish up my guide. So I'm just going to draw half of it, and I just want to go ahead and set up the basic building blocks for it. So what I'm going to do is I'm going to go ahead and relate this guy. Come down here, and I'm going to relate the center of this hole over here to the center, to one of my planes right here, and that way I can go ahead and center that guy up. Don't have to use any dimensions or anything, so let me come down here and let me specify my radius down here. I'm going to get that back to 90. There we go. Got that guy nailed down, got this guy nailed down. So now that's perfectly dead center. The other thing you'll notice over here in the bottom right-hand corner while I'm drawing this, I'm going to go ahead and use this guy. This is a new view cube. I can actually go through some of my views over here and take a look at some of the orientation. Now I can see that this guy is kind of off at an angle, so I'll probably have to go ahead and redo that right quick for you. I forgot to lock onto a plane. So let's go ahead and get that point again. Come out here, let me lock onto my Z and my X. There we go. Let's go about 10 degrees there. And let me draw that arc right this time. So instead of locking onto there we go. Instead of locking onto an axis, what I can do is I can actually lock onto a plane instead, and that's kind of the step that I forgot beforehand. So let me go ahead and just redraw this guy back in, locked in at the correct plane. There we go. Let's go ahead and connect the center back over to the center part there. And let me go ahead and redefine this guy again as well. And let's do 90 degrees. There we go. Now I have this. So now if I come back to my left side, now I can see everything's nice in line now. Some other little tools that we have inside our 3D sketch, I do have the ability to create 3D fillets. So if I come back over here to this corner, I can simply click and I can drag out a fillet here, or I can key it in. Let me go ahead and add a couple of fillets here, and I'll add one more over here to the top. Go ahead and make that a larger radius here. There we go. And you can see what looks like I got a little misalignment, no problem. We can go ahead and re-relate this guy. Center of U to the center of U. There we go. Get you back in there. Okay, so now I have my basic 3D profile. What I'll do is I'll go ahead and hide that lift guide for a bit. Now I want to go ahead and just use my normal plane creation tools, and I'm going to sketch a profile of this, the OD of this guy right here. Wait for that to come up. I know the diameter of it. There we go. Now, simply come in and use my sweep to find the path. And go ahead and project that out automatically on my new 3D sketch. And then to get to the other side, like I said, we'll only draw half of it. The rest of it, we'll just go ahead and use the mirror command. Get the other half. And now I can actually come in here now if I needed to and make a quick little synchronous change. Probably change the diameter of that, and it'll automatically self-adjust. So really quick, using my the new 3D sketch tool, I can quickly create the path, sweep the protrusion up and around, and now I've got my rod over here with my guide. If I hit Control Q again, come back in here, you can see the rest of the assembly. You see it's going right through the center of that lift handle. And if I close this out, let's go ahead and take a look at the rest of our little deep fryer here. We'll rotate this thing around, and if I use my assembly tools, you can see that, well, the guide isn't quite in the correct position as of yet. You can see it's just kind of sitting out here. No problem. We can come back over here and let's go ahead and come down to the lift guide again. Turn on our okay, then we'll just kind of come over here. Now, if we want to reposition this in the correct spot, we'll just have to simply come over here and use our Synchronous Tools. Again, come over here with our steering wheel. We'll line that guy up. Come over here. Now, I want this to be, I want the back side of this flush with the inside part of the sheet metal bracket. I can simply do that by using my steering wheel, offset it, and half the distance of my diameter and use my key points. And help relocate this back over to this edge. There we go. Now we can see it's in the correct spot now. We'll simply close out of this. Come back over here and we'll take a look at the whole design again. Drag the component. Oh, looks like I messed up, lock something down too. Oh, that's right. There we go. Now I can drag the component. There we go. Now we can see it follows that guide up and down. So that's some of the cool things we can do with 3D Sketch. Let me go ahead and show this whole thing. And show the whole thing here. So some of the cool things we can do with 3D Sketch. For fixed curve, let me go ahead and show you that little process right quick. And for that, what I'm going to do is I'm going to go ahead and open up my engine, this engine assembly. And with fixed curve, again, it's a simple little process that's now been added into Solid Edge. I'm going to go into the, going to go open up this engine assembly and go into the turbo part. And what I'm going to do is I'm going to go in. There's a hose that connects the wastegate to the other part of the turbo. And it's right now what it is. It's a variable. It's a regular curve that's in here. So let me go ahead and switch over. Go ahead and come back here. Now let me go ahead and go to my wastegate. There's my turbo there. And what I'm going to do is I'm going to go ahead and open up this part right here. Okay, so here we go. There's my part. And this is the guy I kind of want to go over. Real quick, what I want to do is let me show you what happens right now with it with that curve right now not being locked down. So what I'm going to do, I'm going to reposition my steering wheel over to the center. And as I rotate this hose around, this opening right here, you can actually see the length of my hose is actually going to change and adapt to the synchronous change that I'm making. And in some cases, that'd be all right for you, but say you wanted to go ahead and maintain and constrain the length of this hose. With the tool now added inside Solid Edge with a fixed curve length, let me go in here to my express route. Let's go ahead and take a look at this curve path. Okay, right in here, this is where the change is. Right down here, the fixed curve length. Let me go in here. I can actually come in and specify the length right now. It gives me a readout. It's currently 368.29 millimeters. So if I want to round it off, I could do that and give it an actual fixed length. The other thing I can do is I can constrain it in a single direction. So say when I pull this, I want to go ahead and constrain it on the x-axis. I can also pick some geometry that's sitting up here in the actual part as well. So let me go ahead and constrain it over here to this guy. Accept it out. And now when I make that synchronous change, you'll notice that the length of the hose is going to stay fixed at a certain length, and now just wherever I position this port now, the length of the hose won't change at all with it. So if you're looking for a little more control, that's now available to you inside ST7. Let me go ahead and close out of this. I have a couple of more things I need to show you right quick. And then we're almost ready to go on to the transfer it over to Dylan. So let me go back to my main assembly here, to the entire motor. The next cool thing that they've added into Solid Edge ST7 is a new command that's called duplicating component. Now it's a new patterning method, so it's not quite patterning. It's a brand new technology that's patent pending by Siemens. It's exclusive to us, and what it does is it creates rapid reproduction of parts throughout your entire assembly. And all you have to designate is the from and the to, and it'll automatically reposition your component intelligently in the new location. It doesn't necessarily have to be at the same orientation. It could be angled back about. It could be 50 components that you can pattern this thing 50 times easily. What it'll do is, once you specify the area that you want to duplicate a part from, it'll automatically go in and search your entire assembly for any light component and try to fit that part inside of it. So instead of the way you're used to patterning now, where you go pick the part, pick the face, pick where the pattern needs to go, and accept it out, and then go to the next part, put a new part in, pick the pattern, duplicate it over again. This is way cooler now because it'll automatically go in and search for the light components inside your assembly and place the new parts in there. So to show you that, I've got my engine right here, and very quickly I'm going to go ahead and insert a component. This again, by the way, is new. Coming down here, you can see down here in my preview area, I now have a kind of a color display. I'll go ahead and drag this guy in. Let me go ahead and mate him up. So using some of my flange fit, place this part inside this assembly. Let me go over here, and what I'm going to do is I'm going to duplicate these bolts and this motor mount over here to the other 4 mounts that are available inside the assembly. Now there could be, you can imagine there are probably another 20 of these mounts. All I have to do is simply select them once, and then Solid Edge will actually go in there and find them and place the new components in there. So let me go ahead and just select what I want to duplicate. So let me start off with you and come back and add, going to need that washer. Okay, and what I want to do is I want to go ahead and find all my identical parts there, as well as my mounts. Okay, now with those parts, also the ones I want to duplicate, you can see over here under pattern, I now have duplicate component. Again, you'll see the little little movie down below. And now what it's asking me is, what part is this going to be based on? So I'm going to go ahead and pick that one. I want to duplicate that one over to that guy. And you can see what it'll do with Solid Edge ST7. We'll actually show you a quick little preview of how it's going to duplicate the component to that one spot. Now, if I wanted to go ahead and back over here, I can identify this, or here's the magic. I can actually have Solid Edge look for all matching occurrences. So if I click on that guy, Solid Edge automatically went and looked for this component right here, searched the assembly and found one over here, and found the one on the back side. and you know, it could be from 4 to 50 to 100. It'll look and locate them all regardless of the orientation of them all. Once I hit OK, it'll automatically place it, and you're good to go, saving you time, effort, and it'll go ahead and store it in here in its own little subcategory. I like that one because I used to build trailers and you have to put in lug nuts everywhere. And believe me, that was one heck of a time saver right there if we had this capability. Hey Larry, we're getting a lot of static. There we go. Another
Hey, all, can we ask you to please mute out your phones while we're performing the demonstrations? Thank you.
Another one of the cool improvements that they've made to ST7 is they've added in the capability of creating coordinate dimensions automatically. And we'll probably have this, just because of time constraints, we'll probably show this in a future webinar. But this is a real cool command. All you have to do is simply select the view, and Solid Edge ST7 will automatically place the necessary coordinate dimensions. You can have it set to finding all edges, all circles. It'll automatically place them. You don't have to go in there and pick each individual hole. And it automatically goes ahead and jogs everything in place. So we could have this in a future webinar. But for that concludes my section here, and I can switch it over to Dylan now.
All right. Thanks, Sam.
No problem.
All right, let me get my stuff set up real quick. All right, thanks for joining in. Today, my portion of the seminar, we're going to be talking about some of the new technology in the sheet metal environment of Solid Edge. What they have come up with is what they call ParttoSheet Metal. And basically, it's a command that's in the ordered environment that allows you to create sheet metal from pretty much any type of file you want, whether it's a part or another sheet metal file. All right, so we're going to look at that, and within this same demo, we're going to show you the new hole dialog. Obviously, we've had holes in Solid Edge since it first came out, but they've never had any standards. So now you can put your machinery handbook away because they now have all the standards built into it, whether it's a drill size, tap size, clearance hole, etc. So that's all new in the ST7 demo I'm about to show. And what's also nice about this is the sheet metal, whether it, we can always flatten sheet metal parts. We'll always have problems with deformation features. So new to ST7, we actually adopted this from NX. It's the flatten algorithm that lets you flatten pretty much any surface that you want. So on the left, you can see I actually have a part that will be flattened and give you the blank size. So we have customers that I know use it for generating foam or sheet sizes for pipe insulation, etc. So you can get that template really quick and know how much surface area you're going to need. And on the right is a sheet metal part that I used the flattened blank size to give me a flat pattern of it. It doesn't give you the break patterns like a sheet metal typical flatten was, but a typical flattened sheet metal part, I couldn't do that in Solid Edge with the louvers and that deformed feature on the top. All right, so without further ado, let's go ahead and get into Solid Edge. All right. So the first thing I'm going to do is show you how to create a part in the context of the assembly. I'm going to turn that part into a sheet metal bracket. So on this side, we're actually going to create a bracket in place to mount to the frame to the engine harness. All right, so let's go ahead and hide a few parts here. I'm going to go ahead and hide a few items that I really don't need. There we go. This will be a little faster and easier to see. All right, so again, I'm going to go ahead and create a part in place. I actually do it as a part file, but I'm going to go ahead and do it as a metric template. All right, so I'm going to go ahead and create a part in place. What we have the ability to do now is actually locate our geometry based on locations of parts in the assembly. So I'm going to go ahead and do that. Excuse me, let me go ahead and activate these couple parts here. There we go. Sorry about that. Let's call this bracket. Oh. Sorry. Oh boy, I'm really screwing this up. I didn't actually position where I needed to actually put the part. Sorry about that. Goodness. I think I was sleeping today.
Sorry, Dylan. It looks fine on this end.
All right. There we go. I was not getting that a second ago, so there is my locate point. So that's what I was trying to look for. And I want to go ahead and position this at a particular key point. So let me go ahead and set it to all key points so I can easily find the midpoint here. And you see the glyphs that kind of pop up. You'll notice that there are actually larger glyphs for key points, endpoints. It's a lot easier to see where you're actually at on a part now. So I'm going to go ahead and create that part in place here. And again, I'll just give it a name. Here we go. All right, so now we're back on track. All right, so as I create this part in place, we're going to actually use a new feature in 7. We have some primitive features, box, cylinder, spheres. And again, like Sam showed in his demo, we actually have little videos that kind of show how these primitives work. So I'm going to go ahead and just create a box. And we're going to go ahead and tie to some geometry here. And let me make sure something, yeah, my peers are on, so I'll be able to grab geometry. As you notice, I hover over these edges. Let me zoom up a little bit so I'll make it easier for you to see. I get these big blue dots on the corners, so I know exactly, so maybe I want to go to an intersection or something like that, or an endpoint. Those are a lot easier to see now. All right, so I'm just going to go ahead and create a cube here to line up to my geometry. There we go. And again, you notice what it's going to show here is the projection of that actual sketch. So now it's real easy to see where that projects in the space, and I get my key point. And again, since this is a primitive feature, it automatically goes from the profile right into the actual sketch geometry. So again, it's going to go and tie to some geometry from my design here. All right, so let's go ahead and get it a little more streamlined. Right now, it's kind of big block. Synchronous Tools. You know, we get the ability to grab faces and use the steering wheel to manipulate that. You know, I could have actually done a cutout or you know, drag a face around, but in this instance, I'm going to use the torus to rotate this face down 40 degrees. All right, so we're getting more of a shape that we want to achieve here. Let's go ahead and line up a few faces here. So let's go ahead and line it to the top, and let's go ahead and line it to the bottom. On the top, you know, we can go ahead and just do a cutout. So I'll just, again, we behave just like we do any other environment. We have the ability to grab geometry, and again, Essence allows you to use the open profile to create your geometry. So I'm going to go ahead and project that out there. Let's go ahead and extrude that. And we want to remove some material. There you go. Let me go ahead. I didn't actually get this to the right location. There we go. And again, I wanted to match this face to a piece of geometry. We have the same tools that we had previously, so we're going to go ahead and make a Coplanar Relationship between this face and this outside. Go ahead and get this outside face of this guy. So once we go ahead and create a sheet metal part, which is what we're going to do out of this, we'll have the ability to easily go in and add some other features to lighten it before we actually create this into a sheet metal part. All right, so that's pretty much all the geometry I'm going to use right now. Go ahead and hide that. Again, I'm going to go ahead and use another primitive. Let's go ahead and create a feature on the side. Let's create a lightning hole to add a little, take a little weight out of this guy. I'm going to go ahead and just not even worry about the size right now. I'm going to go ahead and position that afterwards. So quickly, just with PMI dimensions and synchronous are the driving geometry. So I'm going to go ahead and create some dimensions to place this guy. There we go. And go ahead and position them to the other edge as well. Sorry about that. The mouse is being there we go. Put it on the mouse pad. All right. And that'll work. All right, a couple other things we need to do. Since it's going to be a sheet metal part, I want to go ahead and add some flanges to this. I'm going to go add a couple more pieces of geometry here. So let me get a little edge here. All right, so I'm going to go ahead and, since I know this is not going to be in a completely enclosed box, I want this to actually have a flange edge. So you'll see actually what I'm doing here in a moment. So I'm just going to include some edges and actually offset them 15 millimeter. There we go. Do the same thing for this edge. All right. You notice we have regions, as we call it here, but this sketch didn't go all the way to the top. So with the same 2D kind of sketching that you would have in any other sketch, we're going to go ahead and use connect points to go ahead and connect it to its respective edges. And the last thing you need to do is go ahead and draw a line. And we're going to actually use this top surface to do that with. And I'm just going to go ahead and use the key point again that I just created, and draw a straight line there. That will work. All right, so let's go ahead and knock some of this geometry out here. So now I have a closed region. I'm going to drop this face, just a little thicker than I'm going to actually make the part. So I'm going to go ahead down 2 millimeters. Oops. I think I just typed in too much of the distance. Here, let me grab this first. All right, so now, as I mentioned earlier, this is a ordered style of geometry. So I created the body in Synchronous, which allows me to use the steering wheel to quickly create the geometry. Now I'm going to actually go ahead and use an order tool called ParttoSheet Metal. So let's go ahead and go into this and look at the options here. So we can use the default sheet metal options. You can go ahead and just type in your own radiuses and own sheet metal gaps. All right, so then it's just coming a matter of picking some edges. So as I pick some edges, you notice the part actually starts turning translucent. And since we drew the outside diameter or radiuses of the part, we're going to go ahead and point to the inside. And I'll continue on picking some edges. Let's go ahead and grab that edge. There's 2 edges we want to grab here, so we want to go ahead and say that's an edge. Next edge, and let's go ahead and grab this face. All right, so that looks pretty good. You notice these key points, all these types of styles. So, corner, flanges, I can go ahead again right into here. I can go ahead and, let's say, make this a circular cutout. Big. Let's make that a 10 millimeter circular cutout on this corner. And that looks pretty good. And if I want to pick an edge, you notice I actually can grab an edge, and it gives me the actual bend radius of that edge. I can actually pick that and change it on the fly as well. So I can go to each edge, manipulate them, but this part looks pretty good, so I'm going to go ahead and just finish out of it. And there you now have a part that's basically based on a synchronous design. So anytime you want to go back to synchronous and make some synchronous changes to the shape, you're automatically going to go ahead and get the update on your sheet metal part. So again, that probably took a lot longer in sheet metal. I'll guarantee it'll take a lot longer in sheet metal to create that. And what's kind of nice about it is, if you notice, I did the primitive through there, but as you notice, this is a sheet metal part, so it actually recognizes, hey, that's a normal cutout to that face, so it doesn't go straight through. And let's go ahead and, since we're in here, I mentioned in my PowerPoint that we can do some holes and we can do the flatten, and so let's go ahead and take a look at that. All right, so the hole table. All right, so I'm going to go ahead and put some holes on this to go ahead and mount it through. So what I'm going to do is actually create some holes, but I'm going to actually get some measurements first. So these are 6mm bolts. So what I'm going to do is inspect. I don't know the hole spacing, so I can put some PMI dimensions, but we have a new measure tool. All right, this is an assembly part. Anywhere you want to go ahead and use this, it'll work. All right, so I'm just going to go ahead and grab some geometry. Let's go ahead and just say I want to know the distance from here to, let's go ahead and rotate around, let's grab this guy. There we go. All right, so we're looking at 50 by 30. All right, so we have this little cumulative measure tool that, if you want to go ahead and pick surface area, it'll actually keep adding surface areas. But we're going to go ahead and use this just for me to be able to place this. So, that looks good, so I'm going to go ahead and close it. And you notice what we get left with is this measure box. So it actually has this size in here. So I don't have to go right down 50 by 30 and by 6mm holes, etc. So that'll stay there as long as I need it to. So let's go ahead and create a hole. All right, so let's show you some of the new dialogs. As again, I was talking about the general screw clearance, dowel size, drill size. If you do it by clearance holes, you have some options: closed, normal, loose fit. So I need a millimeter hole, so let me go ahead and get a M6. There we go. And let's go with a close fit. That'll work. So it gives me 6.44 millimeters. Looks good. All right, so let's go ahead and place this on here. Looks good. So I'm just going to place one. I could go ahead and do all four, but again, I already have this up here. So since I do, let me just instead of just let's do a pattern of that as opposed to actually creating that as four individual holes. So let me go ahead and grab the hole pattern. There we go. And since we know the actual size, we can go over and say, let's go ahead. I believe that was 50 or 50 by 30. All right, I'm glad I had it up there. All right, there we go. So that looks good. Let me go ahead and close that out. And there's my pattern. And don't need this guy anymore, I'm pretty sure. So let me turn on the parts. And of course, boom, they hit exactly where they're supposed to. All right. So one of the last things to look at is something they've added into your Pathfinder. Instead of the previous days where you had to go to File Properties, go to your Material Table, and apply the geometry. Well, here I'm going to go ahead and give it the Material Table, or give it material from here. So I can actually right-click on the Material Table from my Pathfinder, and you notice I have some favorites. If I want to go to the Material Table, there's been some changes in here as well. You notice things are kind of categorized a lot better now. So I'm going to go ahead and make this part stainless steel. But you know what? I'm going to go ahead and make it of shiny. So I'm going to go ahead and copy this. So it's real simple to right click and go ahead and paste. And we'll go ahead and rename this. We'll call this Stainless BA for bright annealed. All right, so we'll go ahead and create that. That looks good. Let's go ahead and actually modify something. You notice we actually have part colors and textures. maybe I want to go and modify that appearance of that. Maybe since it's bright, I'm going to go ahead and give it a shiny, and let's go ahead and make it a little bit more reflective. All right. Apply. Okay. So now my part's going to have the texture on here. It's going to have metal. So now when I go ahead and there we go. So now I'm going to go ahead and just do a flatten of this guy, just to show you that I converted that part into an actual true flat pattern. So let's go ahead and do that. And there's our flat pattern, again, created within a few minutes from the actual part file. So can't get any easier than that. And again, that works with pretty much any type of file. So let me go ahead and close and return back to my top level. All right, so that looks like a nice fit. The next thing we're going to look at, again, was I was talking about the flat side, or the flat blanks parts. All right, in this one, this is a, let's see, it's the actual sheet metal part, and I can guarantee you, I can convert that into sheet metal, but I wouldn't get all these features to flatten for sure. The actual stiffening bead and this fairly deep draw dimple. All right, so I'm going to go ahead and show you. So what we do is we switch over to the order right here. And inside that ordered, I actually created this blank. And the reason I actually did this predefined is because I did a superfine resolution. So, and then the next part I'll actually show you. I'll go ahead and do it. Sorry. There we go. Went to the wrong file. All right, so there's our blank of that sheet metal part. And again, I did it at the superfine level. Let me go ahead and show you this demo live. And again, for our upholstery people, this will probably be useful. I'm going to go ahead and open this part up. All right, so this is not a sheet metal part. This is actually a part file. So I actually have some surface area here. So I'm going to go ahead and do a flatten of this guy, and we're going to do the blank body. So I'm just going to go ahead and grab that surface, and it's all the surface minus that little area right here. And as I mentioned a while ago, we can do very coarse or very fine. On the other one, I did a very fine. It takes maybe a minute or two to do it, so I just don't want to sit here and wait for that. So I'm just going to go ahead and do this one at a medium. Go ahead and do a preview. If you look at here, it gives you your, some properties you can apply to it, and some alarms that you can set for if it exceeds your blank size. So go ahead and preview that. So this takes maybe a few seconds to go ahead and generate. Yeah, the only criteria is it has to have an open area at one point or another. So once it has an open face, then the rest of the faces can be flattened. Goodness, I didn't think it was going to take this long. Again, I'm using the GoToMeeting, so it does kind of rob some of my resources. All right, well, that's thinking. Let's go ahead and show you one more thing. It's the last demo I'm going to do for today, and it's the big one. Dun, 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 dun. Solid Edge with Keyshots. Actually, Keyshot is now embedded into Solid Edge part or an assembly environment. So you can do renders, high-end renders of your geometry very fast. Solid Edge has some decent rendering capabilities, but nowhere anywhere close to what actual Keyshot can do. All right, so let's go ahead and take a look at that. Oops, back to. All right, well, it's still thinking. Just close out of there. So I can go ahead to the next demo.
Hey, Dylan, I do have a question from the audience. might be a good time. I have a question asking when is ST7 actually going to release or be available for download?
What I'm using is still beta. It's build 98, and I believe right around build 100 is when they really start. It starts to go into press, so they'll start burning DVDs, and at that point it'll be immediately available for download at the Siemens site once that announcement's made. So it's available to anybody on maintenance to immediately go download.
Yeah, Larry.
Yeah.
I just yesterday they released beta version 102.
Ah.
So they've hit the 100. So now it's just pretty much a matter of probably about a week or two maybe.
Yeah.
Okay.
Usually once the 100s come out, it's time to they'll get it out pretty soon. So anytime now.
I thought I had heard that we were going to be able to download it from GTAC about August, and then the media might begin shipping in September.
That is correct.
Yeah, I was curious if you guys had heard anything as well.
No, yeah, they put out beta 100, so anytime now.
Yeah. Yeah.
Okay, great.
All right, I'm back in business. All right, so this last one again is going to deal with Keyshots, and what's really slick about Keyshot is it actually uses the animations from Solid Edge. So what we have here is a calculator that I have a couple animated motors on. So I'm going to go ahead and just show you quickly what these going to be. So basically, I'm going to have a little trigger switch opening, and I'm going to have this door come up. And what I'm going to do is actually let's have it open and close. So I'm just going to quickly do some copying and pasting here. I'm just going to go ahead and mirror that and position that down here, and I'll do the same thing for this. It's going to open and close. I'll just copy and mirror. Oops. Let's go ahead and again, we want that to open and close and click again at the end. So let's go ahead and paste that and do the same thing, copy and mirror here. There we go. So I'm going to just drag this down the timeline. Again, Keyshot will obey the same time frame, so let's go ahead and I'll just show you what this is going to look like. All right, so it's going to click open, it's going to rotate around, then it's going to again close, then click and, oh, got the time frame a little long there on the last one, but I'll just go ahead and leave it as is for now. Let's go ahead and save that. All right. That looks good. Let's go ahead and now, as I said, we have Keyshot. So if you notice, we have a Keyshot animation frame here. And under Tools, ERA, we actually have Keyshot render as well. This takes you to the same environment. So we have it in both places. So I'm going to go ahead and, again, publish this out to Keyshot. So let me go ahead and just hit the Keyshot button. It's going to ask you some information, how fine a resolution you want. So let's go ahead and create a it's creating a bit file, and it's going to actually push this out to Keyshot. And as soon as we get into Keyshot, we can do some pretty slick stuff. And you'll be amazed once you get it. Again, this actually comes with ST7. There we go. All right, so now we're in Keyshot. Let me go ahead and shut down Solid Edge. Actually, no, I'm going to leave Solid Edge open for now. All right, so let's go ahead and show you the animation real quick. It basically makes the same type of timeline Solid Edge does. And let's go ahead and you notice it does the same process. That looks good. So let's go ahead and just stop that and reset it. All right. Since we have the ability to do super high resolution renders, this is a real-time renderer. What's considered basically as I sit and let it refresh, it's rendering as we sit and watch. Let's go ahead while it's doing that. Let's go ahead and add some colors and textures to it. All right. So you know, the outside grips are usually kind of a rubbery material, so let's go ahead and do that. For that, let's go ahead and do the same thing to the keys. Let's go ahead and drag it to the bottom of the keys. Let's add some nice paint to it. Go ahead. go down to metallics. There we go. That looks nice. Let's do the sapphire blue. Same thing there, and let's go ahead. Do it for the battery cover. Then let's go ahead and just add one quick one to the switch. Just make that orange metallic. I need to actually turn the LCD a different color. Let's go ahead and I can open this up, and you can see we have a part tree list just like we get in Solid Edge. Let's go ahead and hide that. Then let's go to some plastics, clear. And let's go ahead and just use a line green on that guy right there. All right. That's all we need to do. All right, so let's go ahead and turn the cover back on. You can hide these. All right, so if I wanted to go ahead and just do a render, so I have two render options here. I have a still image and animation. So you can set the animation, tell it what kind of video output you want, and go ahead and hit render. It's going to actually, depending on how long your animation is really going to depend on how long it's going to actually take. All right, so I already did a predefined one. I already did one last night, so let me go ahead and open that one up. So we go to the renders. There it goes. So just a little loop here, and that took a couple hours to render and animate. So I actually added a camera path in Solid Edge along with the renders. So that wraps up my portion of the demo. So I appreciate your time. And I will pass it back to Larry here. Or Larry, you can take it back.
Okay. Let's see what we got here. Okay. So you should see my screen there.
Yep. See Sam.
All right, Dylan and Sam. Thank you much for the great presentations.
All right.
All right, everybody, just a couple things to cover before we begin the Q&A session. Swoosh is a certified training partner of Siemens PLM software, going all the way back to Solid Edge version 17. And something we're getting a great response from is the new addition of the virtual classroom, specifically when the cost of travel is not an option or when schedules are just too hectic. So please keep that in mind if you do have a training need. Also, a couple things that we do different from the other training partners, and two good reasons why companies select Swoosh to provide their educational services is what they get for the cost and our technical writing capability. At no additional charge, we provide process-specific training for how you use the software as opposed to feature function and clicks. So you come away learning how to create your designs with best practice efficiency. And our technical writing, again, at no additional charge. We can design the course material around what you design and even build your models into the exercises and activities. So you will clearly understand how to connect the features and capabilities in Solid Edge to your design objectives and have a manual with use case studies to refer back to at any time. So, if anyone would like to explore further our educational services, I can put you in contact with one of our training instructors to discuss your requirements, about 15 minutes on the phone. So just contact me. And finally, for the shops that do machine programming, Siemens is offering an end-of-year promotion, discounting 25% off of the software and first year's maintenance for the two qualifying bundles that you see here. Anyone that's familiar, software and maintenance discounted together can be a huge cost savings. So if anyone would like more information, please contact us as soon as you can. This promotion ends after September 19th. Okay, so now we would like to begin the Q&A session,